the child's body surface area. Again, they will either give this to you or you'll have to calculate that out by using one of the formulas above that we just went over. And then you'll divide that by 1.73 square meter. And this 1.73 is the average adult body surface area. Now, some programs may use 1.7 as your number. Some may use 1.73, just use whatever they give you, but whatever, you're going to get the same answer. And then you're going to divide that, and then once you divide that, you'll multiply that by the normal adult dose that was given to you in the scenario, and then that will give you your answer for the child's dose. Now let's solve some different types of scenarios you may encounter on exams that require you to solve for body surface area. So before you do that, of course, you need to have these formulas memorized because that's the key to solving these problems. Second, you need a calculator that is going to solve the square root of values. And then third, you need to make sure you're following the rounding rules set by your program because they may round a little bit differently than how I will round in this video. So always double check. So our first problem says your patient weighs 163 pounds and is 5 feet 7 inches. What is the patient's body surface area? So we need to pull from this scenario the most important information we need to solve this problem. So we know that the height and the weight is very important when solving body surface area. But which formula are we going to use? The metric system formula or the household? Well, they gave us the patient's weight in pounds and the height in inches. So we're going to use the household system formula, which is this formula, because the scenario gave us the patient's weight in pounds and their height in inches. But before we can actually use this scenario, we need to deal with this height because they tell us the patient's height is 5 feet 7 inches. So we need all of that in inches. So to help us do that, we're going to use a little bit of dimensional analysis. So the patient is 5 feet, and we know that in 1 foot, there's 12 inches. And this calculates out the feet, foot, and we're going to multiply everything at the top and everything at the bottom and then divide. So 5 times 12 is 60. 1 times 1 is 1, and that converts to 60 inches. Now, the patient still is a little bit taller than that. They're 7 inches. So we're going to just simply add that leftover inch up there. So 7 inches. 60 plus 7 is 67. So our patient is 67 inches total. Now we are ready to use our formula. So our formula, square meter, which is body surface area, and I'm just going to write that right here so you can see it, equals the patient's weight times the height. So their weight is 163 pounds times 67 inches. And then we are going to divide that by 3,131. And again, don't get that confused with the other formula. That's the key with it. So we're going to divide that by 3,131. Make sure you keep your square root because we do that at the end. So 163 times 6 gives us 10,921. And then we're going to divide that by 3,131. And whenever we do that, we get 3.4880. And we still need to figure out the square root. So the square root of 3.4880 is 1.86. Nearest hundredth, and again, follow your program's rules for that. So you get 1.87 square meters. And that is the patient's body surface area. Our next problem says your patient weighs 27.2 kilograms and is 91 centimeters. What is the patient's body surface area? So you want to pull the most important information out of the scenario to help you solve. So of course the patient's weight is important and their height. So this problem specifically gives the patient's weight in kilograms and their height in centimeters. So we're going to use the metric system formula to look at that body surface area. So we're going to use this formula right here. So let's go ahead and plug in. Everything's ready for us to go. We don't have to convert anything like we did before with the 5 feet 7 inches. So our formula says square meter, which again is the body surface area that we're trying to calculate, equals the weight times the height, and kilograms times centimeters. So 27.2 times 91, and we're actually going to be dividing that out by 3,600. So we're going to put 3,600 down here, and then whenever we're done with that, we have to figure out this. So 27.2 times 91 gives us 2,475.2, and we're going to divide that out by 3,600, and whenever you divide that, you get 0.687, the square root of that. So the square root is the patient's body surface area. Our next problem says a pediatric patient is ordered a medication dose of 10 milligrams per square meter per day by mouth for 7 days. The patient weighs 46 pounds and is 3 feet 9 inches. What is the daily dose of medication the patient will receive? So to solve this problem, we need to pick out the important information we need to know to actually solve what the problem is asking for. So the problem wants to know the daily dose of medication the patient will receive. So to solve for that, we need to know what the physician ordered. The physician ordered 10 milligrams per square meter per day. That's important. Now for 7 days, that's just really a distractor. So we know the patient's going to be getting this for 7 days, but the problem wants to know the daily dose. And because this medication is expressed in square meter, this is a body surface area calculation. So we need to know the patient's height and weight, and they give us the patient's weight in pounds and their height in inches. So we're going to use that household system formula. And again, the formula looks like this. But before we can start with that formula, we have to deal with the 3 feet 9 inches because we need all of that in inches. And to do that, we're going to do some dimensional analysis. So we know the patient is 3 feet. And again,